Hello, this is the third video of the Calculus 1 series on improper integrals for OCR Pure Core Further Mathematics and looks at integrals with the function undefined at a limit. Consider the function f of x equals 1 over the square root of x. This function is not defined at x equals 0, which happens to be one of the limits of the integral in this example. So in this example you can see the limits are 0 and 2. It is difficult to tell whether or not there is a finite numerical answer without looking at this limit. So whereas in the previous videos looking at function 1 over x and 1 over x squared, it looked like the area might run on indefinitely in the horizontal. In this particular example, it looks like the area might run on indefinitely to the vertical. The technique here is to replace that lower limit or problem value with a variable. Again, we'll use a. And as before, we will be looking in the limit, but in this case it's the limit as a tends to 0 because that's what we're replacing. Remembering that 1 over square root of x is x to the minus a half, we can then integrate this. Which gives us, again still looking at that limit of a tends to 0, 2 root 2 minus 2 root a. As we know that when a tends to 0, root a will also tend to 0. This integral is going to converge, and this value here will just become 2 root 2. To summarise the technique, we replace the problem limit with a variable, just as we did in previous videos, and look at what happens in the limit as the variable tends to this problem value. The difference here was that we were looking at the limit as a tends to 0 rather than a tends to infinity. If there is a numerical answer, the integral with function undefined at a limit is convergent. In the next video, we consider integrals that cross a value where the function is undefined.